Hey everybody, I'm going to show you how to use Polar Deep Insights. I'm Chris Mattman. Polar Deep Insights is a project out of USC Data Science. It has two main components. It has an insight generator pipeline. What it can do is it can take data either crawled from the USC Data Science's Sparkler web crawler in raw or parsed form, or simply data on your hard drive in a folder or a set of files, like a set of scientific papers or PDF publications. And what it does is it runs the data through an extraction pipeline. In particular, and here I'm looking at the documentation for the Docker installation, which I'm going to be showing you today. But in particular, that pipeline that it runs the data through does the following things. It either takes the data here from Sparkler, and Sparkler records data to the Apache Solr search service. So it either takes a dump of JSON from that, or it takes a raw dump from Sparkler and parses it, which just removes the sort of surrounding curly brackets and isolates it to a list of JSON structures. Or again, like I said, you can just use a set of files that you have on your directory, which could be, anything. It could be a set of PDF files, HTML, PowerPoints, presentations, whatever, and it runs it through the Apache Tika project, which extracts the raw text. So once it has a set of objects that have extracted raw text, it runs it through a pipeline here in extract.py. What that does is it runs the extracted text through Stanford's Core NLP NER, which is a named entity recognition toolkit. It runs it through the group, so that identifies people, places, things, locations, and so on and so forth. It runs it through a custom geotopic parser that's part of the Apache Tika project, which will identify latitudes and longitudes in data. And then it runs a set of custom data extractors to extract individual statistics about how much text and metadata were generated by the pipeline. That information is then taken and sent to the Elastic Index script. And what that does is it takes the JSON data that extract.py generates and then posts it to a local Elasticsearch web service. So entrypoint.sh packages it all up. It puts together the PDI generation pipeline, and then there's a corresponding entry point for the other service that's part of this Docker pipeline, which is the Insight Visualizer. And what Insight Visualizer is, and it's documented down here, is it's basically a local Elasticsearch, a local Apache web server, and a local Grunt JavaScript server that exposes the AngularJS Polar Deep Insights websites. So they're all pulled together through this docker compose command, in which we give it a starting point for where the data is, either the Sparkler data, raw or parsed, or the individual files. And so the layout of that data directory should look like this. These two files, Polar Data Mappings and Polar Data.json, they come from our production Elasticsearch service at polar.usc.edu. And so you should check out the prerequisites here, which tell you how to generate those files by contacting that Elasticsearch service locally. You'll need those before you start this process. And then once you have those files, you'll want a directory structure that looks a little bit like this: Sparkler, raw, and parsed, files, and ingest. And again, files can be any file type in any folder. Raw Sparkler data is just what you get from curling the local Solr JSON, and there's a script to do that above. And then parsed is the resulting information that you get from running parse.py to prepare the raw Sparkler data and get it to just be JSON objects. So in this example, I'm going to go ahead and start up the Docker for both the PDI JSON pipeline as well as so for the Insight generator, and also for the Insight Visualizer. And so this one Docker command here literally is what I'm going to need to get this up and running. And because I've gone ahead and pulled the USC Data Science PDI generator as well as the Polar Deep Insights, the Insight Visualizer, all of this will run really fast on my machine. Initially on yours, it might take a little bit longer because you're going to have to download those subsequent images from Docker Hub. So we've conveniently pushed them to Docker Hub so that they're available. So I'm going to go ahead and open up a few command line windows just to kind of show you what's going on here and to give you a demo of this. Go ahead and close that. So the first window, I'm going to go ahead and go to my checkout of Polar Deep Insights. And then I'm going to go to the Docker folder, and you'll notice this also has that README along with the Insight Generator and Insight Visualizer Docker files, as well as this Docker Compose file. So if I show you what's in this Docker Compose, again, it's going to go ahead and start up these two images for Polar Deep Insights and for PDI Generator and expose the subsequent ports. So I'm going to show you the contents of Data Polar on my machine. I'm sorry. My Data Polar, it doesn't have to be at Data Polar. It could be at any particular directory path. We're just going to go ahead and specify it in this environment variable here, which is called PDI JSON path. So for me, my Data Polar directory actually lives at home git Polar Deep Insights Docker data. So I'm going to go ahead and save that command, but I'm just going to show you what the directory structure looks like. So you notice that files directory, the ingest directory, you'll notice the polar data mappings.json. Here I have a tarball that I had tarted up. This measurement index.json you don't need, and you'll notice the sparkler file. So if I show you, folder, you'll notice the parsed and the raw directories. Parse.off is because I don't want it to recognize that there's a parsed sparkler directory there, and I'm going to go ahead and move sparkler raw to sparkler raw.off so that it doesn't recognize either of those, because I actually want it to go ahead and read the data from the files directory, which is present right here. And you'll see here. So this is going to be the directory that I start the Docker Compose from. In this window, I'm going to go ahead and get set up two commands, the Docker logs, which shows us the output from a running container. I'm going to get this set up to be pointing to, this is what's going to log the PDI generator, and I'm going to set this up to log Polar Deep Insights. These are going to be the container names for that. So I'm going to go ahead and grab that command that I had right here. Notice for me, again, it wasn't at Data Polar. That's not a full requirement. It doesn't have to be at Data Polar. And so I'm going to go ahead and start this up. So it's created the two containers. You can see by the done command there. So I'm going to go ahead and tail what's going on in the container. So in this container, which is the Insight Visualizer, it's waiting for Elasticsearch to be ready. It's the one that's going to go ahead and start up Elasticsearch. You'll notice it finally started up. It started up on port 9200, and the first thing that it's doing is it's importing the schema that we downloaded from polar.usc.edu's Elasticsearch, and now it's importing the data, which you'll notice is fairly large. It's about 631 megabytes of JSON for all the different records that we exported from it. So that's going to take quite a while. Over here in PDI Generator, it's going to go ahead and wait for Elasticsearch to be ready, and this takes generally a little bit longer than the Insight. The Insight Generator Docker takes a little while to recognize Elasticsearch has started, and that's due to the way that Docker sets up the network. It's going to recognize it here in a second, and once it does, it's going to go ahead and start the local services that it requires, which are Grobid, Tika, Lucene GeoGazetteer, which is the geotopic parser, and you'll notice that it did that. It quickly started Tika server, the Lucene GeoGazetteer, it started Grobid quantities. Here, Grobid quantities takes a little bit of time to start, so it's going to go ahead and wait for it while it starts. So in the meanwhile, while this is going on, you can go ahead and visit sort of the following URLs. You can see Elasticsearch on localhost. It's up and running. You can tell it's here. And the way that I knew that it was there, and I'll just go ahead and pull back up the GitHub documentation, is that the GitHub documentation told me down here at the bottom that for the Insight Visualizer container, it's going to go ahead and expose the Apache 2 web server. And what it exposes is localhost Elasticsearch and also localhost PDI. But localhost PDI is not going to be available yet. That's our localhost version of and I'll show you. That's our localhost version of the Angular app for Polar Deep Insights. It's not ready yet. And the reason it's not ready is that it only starts after it finishes importing all the records into Elasticsearch. So in the meanwhile, what's happening over here while Grobit is waiting to start is eventually Grobit's going to start. And what it's going to do is it's going to go ahead and recognize that I've got PDF files in my data directory underneath files. And you'll notice I have a directory here called papers, and I've got 4 PDF files in here. These are a few of my publications related to climate, graph algorithms to detect mesoscale convective complexes and climate modeling and so forth. So we expect things like measurements, location names, authors, and names and other stuff to be extracted from this data. And so we anticipate that it will. So Grobit takes quite a while to start, so just give it some time. It's going to go ahead and wait till it starts up before kind of kicking off the next things in PDI generator or the Insight generator pipeline. And then over here again in the Insight visualizer, it's simply also importing the initial Elasticsearch dump from polar.usc.edu, and again, that's quite a bit of data, so this is going to take a while too to get going. But eventually here, Grobit's going to go ahead and start, and when it does, we'll also look for some other output that I'll be able to show you. You can see that it's making progress down here. Again, this is just going to go ahead and spin wait loop until it detects that Grobit has started up on that particular port. It's going to go ahead and go to sleep every 2 seconds. That's why you see it waking up every 2 seconds there. While we're waiting, I'll just show you the documentation on that. So Grobit is running on port 8060, and so that's the service that it's going to be exposed by that. That's a REST service that you give a text and it extracts out measurement quantities. The Apache Tika REST service, we give it any type of document and it gives us text. That's going to be useful when we call the Tika prepare Python script there as part of the Insight generator pipeline. And the other service is the geotopic parser, which is going to take a text place name and convert it to a latitude and longitude pair, and there's a REST service that's exposed for that. So that's on 8765, Tika's on 9998, and Grobit's on 8060. Let's go ahead and see if Grobit had started yet. So Grobit still hasn't started. And finally it started. Okay, so yeah, I told you it takes quite a bit of time for it to actually start. So what this is doing right now is it's actually calling Apache Tika and preparing JSONs from its mapped directory data polar, which on my non-container system is in my home Git directory for Polar Deep Insights under the Docker folder. So so what this is doing again is it's preparing Tika data and getting it ready for Elasticsearch ingestion. You get log output here, but there's another way to get log output. What I like to do is I like to go ahead and log on to the specific container for PDI generator. So I know that that container name is PDI generator 1, and I like to log on to the system with bash. And the log file is actually located in the deploy requirements log directory, and you can go, there are 2 log files. There's PDI generator and PDI ingest.log. So I like to tail the results of both of these. So I notice here on PDI ingest, this is where you're going to see the system actually going through the text that it extracts and generating the big JSON datas here. And in particular, I think there were 4 PDF files, so we should expect it to generate 4 JSONs. And these JSONs that are being generated are the extracted text as it's going through the pipeline, and as Grobit is being called to extract measurements, as Stanford Core NLP NER is being called to extract named entities, and as the geotopic parser, Lucene GeoGazetteer, is being called to extract latitudes and longitudes. And we see some of these come out here. You know, we can see measurements being extracted here. These are these things with offsets and units. I saw just a second ago things like place names and so forth. I imagine here We might see some latitudes and longitudes here in a second. And so here it looks like it did what it needed to do to generate the 4 JSON files, and you see them here output 0123.json. The next thing that it does is it actually collects the common measurement names from those output files, those categories, and it creates a new index to store the generated measurements as well. So that's what it's doing right here. And the final step it does is it actually goes ahead and posts those JSON files to Elasticsearch as well. And I think that's, in order to see that, we're going to need to look at PDI generator. I wonder if, I think it might have finished doing that. Let's go ahead and check. Go back and look at PDI adjust. So you can always tell what's going on by simply checking Elasticsearch. And so for us, we can take a look at a couple things. We can look at the indices that are available. And so for us, we care about an insight generator. We can see an insight generator. Doesn't look like it's generated any documents there yet. It's added the measurements, but I'm not sure that it's generated the documents. One easy way to check on that is to go to insight generator and then just simply do a search. Okay, looks like we have our 4 documents that have been generated. So it looks like the PDI extraction pipeline is done. So we're going to go ahead and leave that there, and let's take a look at where our Insight visualizer is. So it looks like it's still working on importing the Elasticsearch data from the Trek Polar dataset from polar.usc.edu, as well as a couple of crawls of the NSIDC. So these are very large and heavily curated data sets that you get with the Polar Deep Insights Docker. So one of the benefits of that is that you're not just getting the ability to do ingest on your own of crawled polar data or other scientific data, but you're also getting information that we've already collected in the polar domain, the Trek DD polar dataset. In case you're not familiar with Trek DD, you can take a look at it here. This has a description of it in my GitHub. So this is the Trek DD polar dataset. So this data was collected over a year and a half, almost 2 years time span, and it's 17 distinct web crawls across formerly the National Science Foundation's ACADIS website, which was their old Arctic data and information system before the arcticdata.io site was available, as well as NSIDC's Arctic Data Explorer before NSIDC Search was available, and also NASA's Antarctic Master Directory. So this is a public data set that you can use. We go ahead and download the descriptions of this data set from polar.usc.edu, so all the Elasticsearch extractions. And so that's actually what it's doing here. It's importing those extractions so that you can play around with them in your Polar Deep Insight visualizer. So, okay, it went ahead and completed. So now it's going to go ahead and start the Grunt web application, the AngularJS web application locally. So it shouldn't take too long. As soon as it says waiting to serve, we're ready to view our own local version of this, and we can take a look. Okay, so it's waiting, so it looks like it's ready. So we should be able to visit localhost PDI, and we're able to do that. And so you can see this is our own local version of Polar Deep Insights. A couple of things that you need to change the default values for. If it's not set already, you need to make sure Elasticsearch is pointing at the localhost version on your host system. You need to make sure that it's pointed to the data that you just extracted. So that's the insight generator index that we created. The default extraction doc type is called docs. Our measurements index is called insight generator measurements. The doc type is called raw measurements, and you'll want to get the entity count JSON. These are 2 static files, which are a count of the entities that are present in your data, along with the suite ontology, which is a way to classify polar data. We also have use the NSF's Clear Earth ontology as well, but we ship Sweet and Clear Earth for that. So these are two static files. You'll want to make sure that they're pointing at localhost/data as a prefix on both of them. So we'll go ahead and download the ontology to local storage. We'll download the document counts, so you notice that that's gone away. Another thing that we want to do is go to the extracted measurements. So let's go ahead and download these. It's going to take a little bit of time because there's so many of them. You can tell by the fact that there are many, many groups of these measurements. So we'll just wait while it downloads them. So it was able to successfully download them. So I click OK. So now hold on one sec. So it's going to take a second to recognize this because there are so many extracted measurements. And we can see the different groups of measurements that are extracted sort of in the background there. There's time, electric charge, frequency, length, and then a bunch of measurements, and then how many times they appeared or were extracted from the document. So we'll just wait here while this realizes that I clicked OK. We'll save that. So it went ahead and persisted them. We'll go back to configure. We'll save this. And then we'll go to the query interface. And what we'll see is that there are 4 documents that it extracted. This is the amount of information in bytes that it extracted from this. So, in this particular case, it extracted, let's see, 6 kilobytes. That's 66 kilobytes. That's 566 kilobytes, or about 5 megabytes in terms of the sum of information from the data. This is the extracted file size. This is the information extracted, which is the ratio of the extracted file size. The extracted text size over the size of the file themselves, and we compute a metadata extracted ratio as well. So these are the result of running the stats extractors. You can tell the types of entities that we extracted from the content in terms of extracted terms and distinct extracted terms that map to an ontology, and you see some visualizations of that right here. So immediately we can click on date distribution and look at the dates that were extracted from the text as well, and you notice that they go all the way up to around 2020 on that, which makes sense. There's a gap from 2014 to 2020, which kind of makes sense because the papers that we extracted information from were sort of discussing information in that time span. And the 2020 value comes from, I believe, the Nature paper that I published, which references what's going to be the future of data in 2020. Geographic distribution, these are all the extracted, these are the density of and names of extracted places, as well as their latitudes and longitudes mapped onto a map for that. So you can see the mentions of locations that appeared in the text, anywhere in the text for that. And we can do all sorts of things, like we can see the average, the count of documents they appear in, the sum, the maximum, the minimum. You can see the correlation of the extracted concepts to any of the ontologies that we have, and in particular, since these weren't data sets that dealt with the polar domain, they were dealing with storm convective complexes, mesoscale convective complexes, and things like that. They didn't necessarily map to the polar domain ontology that we have, but if they did, you would get correlations of those mapping terms right here. You can get popular entities that are extracted in terms of places, organizations, people, time, money, and percentages. These are the extractions from the Stanford Toolkit. You can get the measurement distribution for that. These are normalized SI unit measurements. So you can see here it's extracted some measurement values related to time in seconds, and I can look at the bucket bins, which are bucket ranges for that. So here it's discussing how many documents, fell into the range of 10 to 12 seconds, and it computes an average as well as the specific values within that. And the same goes here for how many fell into the 18 to 20 second bin. We can also look at raw measurements. We can click on that, and you can see that it extracted things like year, days, and seconds, and so forth, and how many times they appeared in the document. And finally, we can look at things like regions of interest. So these are regions of interest, and a sort of heat map of how many times those particular locations were mentioned in the text. Again, we can look at average, we can look at term frequency, term occurrence frequency, and things like that. If this were polar data, we can go to this concept editor right here, which allows us to browse and look at the ontology here. And this particular ontology, again, is the Sweet ontology, for that. But again, we can load other things like the Clear Earth ontology and so on and so forth. So yeah, basically what I've showed you is how to run the Docker here to run Polar Deep Insights locally. I hope this has been useful to you, and look forward to making more of these videos in the future. Thank you.